Okay, now we're gonna look at the schematic diagram so we can understand what we're gonna do today. We get an input of 120 volts, usually the primary coil. This is the secondary coil. Now, what we're gonna have is gonna have an input of AC. That means the two wires are gonna be alternated, switch it from positive and negative, negative to positive, and positive negative. Just like we do. This is what happened with AC input. Now on this project we're gonna use diodes. I'm gonna explain the way they work. Um, a diode only allows current to follow to one direction. So if this end is positive, we'll have the other end flow negative. But if we try to make this side positive and this side negative, we'll have no current going through. So we're going to apply this principle to a schematic. We have positive on the top water, and then we have negative on the bottom water. So the positive voltage will go through here, and then it's going to cause this dial to be turned on. Therefore, the plus will go through the top of the wire and come out to here. On the other side, the negative wire of the transformer, it's connected to these two dials. But remember, this one's gonna be on, and this one is gonna be on, and it's gonna work almost like a switch where the current will go through here till the end. In this case, these two dials are going to be on and these two are going to be off. Now, just like I said before, AC current switch in a fraction of a second. So let's try now that the current has changed, and the top wire is going to be negative and the bottom one is going to be positive. The negative, it's going to go through this dial, but now this dial is going to be off, and it's going to go through this one. On the other side, the positive wire, it's going to go through here, and therefore this one's going to be on because it's positive on the back end of the dial, and the other one's going to be off. So the positive voltage is going to end up going through here, and the negative, it's connected here, and it'll go through this wire here. So regardless of which wire it's positive or negative, it always has positive here and negative coming here. That's what direct current is, and that's what we're looking for in this project.
Now we're going to look at our voltage graphs of two different places in the circuit. Over here we'll look at the voltage graph of the output of the transformer. So here's how our graph will look like. And this is AC. Over here we're going to look at the output of our rectifier bridge, and here's how our graph will look like. So what the rectifier bridge does is whenever the voltage tries to go negative, the wires will switch. So over here is going to try to go negative, so it switches the wires so we get another peak instead of it going negative. So now we're going to explain our smoothing capacitor. So here's our smoothing capacitor.
Jeez, dude, that's horrible. Ricky.
And we don't want our graph to look like this. One wire is always, the voltage is always positive, but we want it to be smooth instead of pulsating like this. So the smoothing capacitor will smooth out the graph. So we want the graph to look like this instead. So this is constant, and this is what we would get from a battery. So the smoothing capacitor is kind of like a sponge. So whenever the voltage is high, it will, just like right here, it will soak up the extra charge. And whenever the voltage is low, like right here, it will release the excess charge. So it will result in a smoother and a more constant voltage. So the graph will now look like this.